This is a presentation about Objective-C written and narrated by Elizabeth Collins. This presentation addresses the history of Objective-C and it examines the similarities and differences between Objective-C and C++. What is Objective-C? Where did it come from? In the early 1970s, C was developed as a procedural language. During the same time period, Smalltalk was developed as the first real object-oriented programming language. Objective-C was created as a superset of C to allow it to perform the object orientation introduced in Smalltalk. And when we say superset, Objective-C basically works inside a C compiler, but allowing it to perform object orientation, which was not allowed in original C. There are some special syntax rules that identify to the compiler what statements are Objective-C from those that are regular C. This includes square brackets, @ symbols, and the capital letters NS, which stand for Next Step, which was a company that was a founder of Objective-C, did a lot of work with it, and was later purchased by Apple Corporation. Objective-C has made such improvements to the C language that it is now the primary language used for programming apps run on MacBooks, iPads, and iPhones, which are all produced by the Apple Corporation. There are many similarities between Objective-C and C++. Both of these languages were based on C and Smalltalk, and both of them are object-oriented languages. This means that in both languages you can create classes and define special methods that can be used for those classes. You can then use a class as a base class to create another class, allowing the new class to inherit characteristics of the base class. The data members and methods for each instance of the class are encapsulated inside that object. In both languages, classes are built in separate files, which are then included in the main program file. The class definitions are contained in a file with a .h file extension. These are known as header files. Usual conventions are that you name the file by the class name, such as for a class named car, you would put the definitions in a file named car.h. Implementations of the classes are then written in a separate file with the same name but a different file extension. A few other basic similarities are that both languages allow you to include comments within the code by preceding them with double forward slashes. They both require the program to start inside a function named main that has a return type of integer. Additional functions can be declared, called, and implemented the same way in both languages. Curly braces are used in both languages to enclose a section of code. They are used at the beginning and end of each function to separate it from other functions. They are also used to enclose loops, switches, and if-else statements. If the term break is encountered within that section of code, it will cause the program to exit that section, ignoring any code that follows the break statement to the end of that section. If the term continue is encountered, it will cause the program to return to the beginning of that section and restart it. A semicolon is required in both languages to terminate each line of code. Loops, switches, and if-else statement blocks are a slight exception to this rule. Since both of these languages are white space insensitive, the program does not consider a line complete until it encounters a semicolon. In both languages, if-else, switch, for, while, and do-while statements are executed identically. Also, variable declarations and assignments, as well as arithmetic, comparator, and logical operators are all the same. These syntaxes came from C, and both languages kept them the same in their implementations. On this slide, we have some sample code that could be executed in either Objective-C or C++ because it would execute exactly the same in both languages. We begin with a declaration of a function we will call from main. This function is called letter, and it takes one parameter, an integer, and it returns a character type. Then inside main, we first declare an integer named num, and we set it equal to 56. Next, we have an if statement that is going to evaluate the state of our variable num. First, it checks to see if num is greater than or equal to 65. and less than or equal to 90. If this is true, the following statement will execute. If not, it will then go on to check to see if num is greater than or equal to 97 and less than or equal to 122. If this is true, the following statement will execute, and if not, the statement will be skipped altogether because neither of the parameters were met. The statement that will execute based on the result of the comparison performed is that we will create a char variable named ASCII, and we will make it equal to the return value of the function letter. We will call that function with the num variable passed to it. Inside the letter function, we will simply return the character value of the integer passed into the function. Therefore, whatever ASCII character that integer corresponds to will be returned to the main program and assigned to the ASCII variable. Finally, once back in main, we return the integer 0, and this is to let the system know that the program executed successfully. Now we will examine some of the things that look different in Objective-C. When defining classes, Objective-C requires the definition file to begin with the term @interface, and the file containing the implementations for the class must begin with the term @implementation. Both of those files must end with the term @end. The file containing the implementation will also have a .m file extension. Inside the program code, object methods are called by using the following format shown here. Within a set of square brackets, we have the object name, followed by a space, followed by the function name, and then if parameters are needed to be passed to that function, we have a colon separating the function name from each parameter that is needed to be passed to that function. You can have no parameters, which would mean there would be no colons and the ending square bracket would come directly after the function name. Or if you have multiple parameters, each one would be separated by a colon after the function name. Objective-C, unlike C++, can only simulate multiple inheritance. This means that when a base class is used to create another class, the new class inherits only the member functions, not the class-specific functions or the data members. Also, in Objective-C classes, only the data members can be listed as protected or private, so that they cannot be accessed by unauthorized functions. Objective-C also has two pretty cool, unique features about it. First, we have a type called ID, which can be used in a program to point to an undetermined type of variable. If the programmer does not know at that time what type of variable it's going to be, they can use the ID type. Then at runtime, the variable type will be determined and the code will automatically execute properly whatever statements or function calls can be used with that type of variable. Secondly, the class methods can be added at runtime without having to go back and modify the original object. So if you needed to add some functionality to a class that you've already created and built and instantiated an object, you can go ahead and add that functionality at runtime instead of going back and having to edit all of your code. The last three things here are simply syntax differences between the languages. On the preprocessor directives, libraries are added in Objective-C by using the term #import. Writing is going to be displayed onto the screen by using the capital NS log function. And string literals are going to be preceded by an @ symbol, and the string itself will be surrounded by quotation marks. The @ symbol is just to identify to the compiler that this is not a C type of variable, because strings were not allowed in the basic C language. This is now a list of the different things you will see in C++ as compared to our previous slide. In C++, you can write both the class definitions and their implementations in the same .h header file if you would like to. However, if you do want to separate the implementations, they would be contained in a file with the same name but a .cpp file extension. instead of a .m that you would find in Objective-C. Object methods are going to be called using the format seen here, which is different than Objective-C. In C++, you will see the object name followed by a period with no spaces in between, followed by the function name, again with no spaces, followed by open and close parentheses. If there are no parameters that need to be passed to that function, you will just have an open and close parentheses and nothing further. However, if there are parameters, variables that need to be passed to that function, they will be listed inside those parentheses, and each variable will be separated by a comma. In C++, multiple inheritance is going to be built in, meaning that if a class is created from a base class, all of the methods and data members from that base class will be inherited by the new class, not just the instance methods. Also in C++, both class methods and data members can be listed as protected or private, and this can allow you to have class methods that can only be called by other methods within the class or friends of that class. And the last three items here are small syntax differences seen in C++ as compared to Objective-C. Again, the preprocessor directives in C++ libraries are going to be added using the term #include instead of the #import as in Objective-C. Writing is going to be displayed on screen by using the term cout. That's a function from the std library. And string literals are going to be surrounded by quotation marks, but there is no @ symbol needed in front of them. This slide here is some basic sample code of Objective-C, and it breaks it down into the .h file for the interface, the .m file for implementation, and then the main.m file, which is going to import that header file and has the main function that will call the object instances from there. Again, in the .h file, you can see it begins with the @interface, ends with the @end term. The implementation file begins with the @implementation term and ends with the @end term. Other than that, it's going to look pretty similar to what you're going to see in C++. And in the main function here, at the top, you're going to see the #import term, and inside the function, you're going to see the object instance method called, and that is going to be different than what you're going to see in C++. Other than that, inside the main function, it's pretty much going to look the same. Here we have the C++ code that's going to do the same thing as what we showed you in the previous slide. Again, the .h file for the class definitions, the .cpp file for the class implementations, and then the main.cpp file for the main function here. That is going to have the #include class name.h. And these look very similar, except for, in C++ you don't have to have the @interface and @implementation beginning those two separate files, and the call to the instance method from the main function looks different. In conclusion here, Objective-C is a C-based language. It is going to be very similar to C++. There are a few key differences that we went over here, a few key things that Objective-C has that are cool features that C++ does not have. Also, if you're going to be doing any programming for Apple, any type of apps for an iPhone or iPad, you're going to have to do it in Objective-C because that's what they use. But other than that, there's really just some small syntactic differences, but everything else is going to be very similar between these two languages. Thank you.